Here we are on page 12, and page 12 kind of takes, it continues on from where we left at the end of where we left off at the end of page 11. At the end of page 11, they ask us what's the relationship between the discriminant and the quadratic equation. Well, the relationship is the discriminant is part of the quadratic equation. It's the part of the quadratic equation that sits underneath the square root sign. What happens when the discriminant is negative? When the discriminant is negative, there's no solutions for the square root, and you end up with no solutions for the quadratic equation, which means there are no x-intercepts, which means the parabola does not cross the x-axis because there's no solutions, right? If there's one solution, the quadratic touches the x-axis at one point. If there's two solutions, it means it crosses at 2 points, and if there's no solutions, it means it does not cross at all. So, when we look at these three drawings here, just from the drawings, without even looking at these equations, we can tell which has a positive 0 and negative discriminant. Because we know that if the parabola does not cross the x-axis at all, like in this case, we know that there are 0 solutions, which means that the discriminant was negative. So we could say the discriminant here was negative. And then here, it touches exactly at 1 point, which means there was one solution, which means the discriminant was 0. And here, there is 2 crossing points, which means there's 2 solutions, which means the discriminant is positive. And if you forget which is which, just think back to the fact that, okay, if I have square root of 0, how many solutions are there? There's just 1. If I have square root of a negative number, how many solutions are there? I'm sorry, there's one solution that is 0, okay? If I have square root of a negative number, how many solutions there are there? 0 solutions. And if I have square root of a positive number, how many solutions are there? Well, there's always plus or minus. There's the positive solution, there's the negative solution. For example, square root of 4 can be positive 2 or negative 2. So actually there's 2 solutions. All right? Okay. Positive definite and negative definite quadratics. Positive definite means the parabola is always positive. Negative definite means the parabola is always negative. So in this drawing, we have the quadratic always above the x-axis, which means it's positive definite. Here we have the parabola always below the negative axis, or always below the x-axis, which means it's negative definite. Do you notice how the parabola continues going up here? So it's never going to cross the x-axis. It's always going to be positive. And here, it's always going to be going down, which means it's always going to be negative. Okay, so that's just what that means. Positive definite means it doesn't cross the x-axis. It's always above it. Negative definite means it never crosses the x-axis. It's always below it. Okay. So number 2. Show that x squared minus 3x plus 6 is greater than 0 for all x. Okay. The way we could do that is we could show that the discriminant is such that it's positive definite. Okay? So for this case where it's positive definite, what would the discriminant be? Well, the discriminant would have to be less than 0, right? If the discriminant is less than 0, that means it never crosses the x-axis. Once you do that, the only thing you would need to show is, hey, the parabola opens up, or the parabola, at one of the points of the parabola is positive. Once you prove that, then the rest of the points always have to have a positive y-coordinate also. It's easier if I show you with this example. Okay, it says to show that this quadratic equation is always greater than 0. Which is another way of saying that this parabola is positive definite, okay? This quadratic is positive definite. So if we know that it has to do with positive or negative definite, one thing that we want to do is find the discriminant. And we want to show that the discriminant is negative, because in both cases, here and here, the discriminant is negative, which means it doesn't cross the x-axis. So I'm going to put the formula for a discriminant, which is delta equals b squared minus 4ac. And then the b squared value is negative 3, so it's negative 3 squared, minus 4, minus a, which is 1, minus c, which is 6. Okay, and then I'm going to put 9 minus 24. And then that's going to be negative 13? No, negative 15. Okay, So the discriminant is negative. The important thing is that it's negative, okay? Once we know that the discriminant is negative, we know that it doesn't cross the x-axis. Now we need to prove that that it's above, that it's positive definite. One way you could do that is with the a value. Since the a value is positive 1, that means it opens up. So that means it is positive definite. Okay, so that's one way. The other way you could do it is you could plug in one value of x, like x equals 0 is often an easy one. Okay, if you put x equals 0 in here, you're going to get the c value, which is 6. So you're going to say at x equals 0, y equals 6. So you've already shown that one of the points is above the x-axis. Once you show that one of the points is above the x-axis and you know it never crosses, you know that all the points are above the x-axis. So you've just proven it there. Okay? All right, let's go to B. B is really tricky. I fell into this trap. Pause it. Why don't you see if you fall into the same trap? Okay, now that you're back. Okay, when you look at this, you might look at this really quick and say that A equals 4, B equals -1, C equals -6, but then you might get the wrong discriminant. You get a discriminant that's positive, and you're like, what the heck happened? I want the discriminant to be negative. Is the book wrong? No, it's not. Look at that. Negative x squared, they put it second, so that was pretty tricky. Negative x squared is the a value, right? So if we rewrite this in the proper order, or in the customary order, we put negative x squared plus 4x minus 6, our a value is -1, right? So let's find the discriminant. It's going to be b squared, so it's 4 times 4 is 16, minus 4 times a, which is -1, times c, which is -6. So we're going to get 16 minus 24, which is a negative number. So we've proven that the discriminant is less than 0, which means that the parabola does not cross the x-axis. And then we're going to show that one of the points of the parabola is less than the x-axis, or below the x-axis. So we're just going to put x equals 0. And if we put x equals 0, then the y value turns out to be -6. So yeah, it is under, this point is under the x-axis, and we know it never crosses the x-axis, so it's always below the x-axis. Okay, let's move on to C. I'm just going to shrink this down so we have a little bit more space. Okay, let's do C. C. So now we have an a value of 2, a b value of -4, and c value of +7, and we're going to show that it's positive definite. So the first thing we want to show is the discriminant is negative. So we're going to put -4 squared minus 4 times 2 times 7. We're going to have b squared, which is 16, minus 56. So this is definitely less than 0. So the discriminant is negative. And then we're going to show it's positive definite by either saying, hey, look, the a value is positive. It opens up. So it's positive definite. Okay? The other way is you could put in x equals 0 and show that one of the points is above the x-axis. And so all the points have to be above the x-axis. Okay. Let's see, we'll put C down here. Now let's do D. Okay, so D, it says to show that it's negative definite. So again, we always want to show that the discriminant is negative, so that it doesn't cross the x-axis. Negative definite doesn't mean the discriminant is negative necessarily. The discriminant is negative because we don't want it to cross the x-axis. So even for positive definite, we do want the discriminant to be negative. Okay, so b squared would be 3 squared, which is 9, minus 4 times a, which is -2, minus times c, which is -4. So here we have 9 times 9 minus 32. And so this is definitely less than 0. The discriminant is negative, like we had hoped. Okay, and then to prove that it's negative definite, we could just look at the a value. The a value is -2, right? If the a value is -2, that means it opens down, so it's going to be negative definite. All right, let's go down to number 3. Explain why 3x squared plus kx minus 1 is never positive definite for any value of x. Okay, so now we're getting into the territory where you guys that are a little weak in algebra are going to really struggle. Okay, so try to follow this, but if you need to come after school to work on these types of problems, I totally understand and encourage you to do that. It's not like just watching me do 2 algebra problems that all of a sudden you're going to be good at algebra. Okay, so here we have 3x squared plus kx minus 1. And let's say if we want to show that it's not positive definite or that it is positive definite, then we do want to find the discriminant. So in this case, we don't know if the discriminant should be positive or negative. I haven't really thought about it yet, but let's find the discriminant anyway. So it's going to be, this is kind of tricky. This k value is not a variable. It's a constant. It's a number that we don't know what the value is of. It's like 3 or 2, but we don't know what it is. So let's say it's just, we'll just put k here as if it was a number, and we'll know it's b squared, so it's k squared minus 4 times a times c. And so basically we have k squared plus 12, right? So we have a discriminant of k squared plus 12. Now we just need to figure out, okay, is the discriminant positive or negative? Well, it says to explain why this function is never positive definite. Never positive definite. Huh. Okay, so basically what they're saying is that, well, let's look at if it is positive definite, then the discriminant would be negative, right? So can this function be negative? Well, try to think of a value of k you could plug in here and make it negative. Is there any value of k that could make this negative? If you put in a negative value of k, it'll give you a positive number because a negative number squared is positive, and then you add 12 to it, it's even more positive. If you put a positive number in a k, of course the square is going to be also positive. So basically, like any k makes delta equals k squared plus 12 greater than 0, so never positive definite. By the way, also never negative definite, right? Because if the discriminant is positive, it's not going to be positive definite or negative definite. It's just that we know there's no chance of it being negative definite because the a value is positive, so it opens up, okay? So we know that since the discriminant is greater than 0 and it opens up, it's always going to look like this. It's always going to cross the x-axis at 2 points, okay? The discriminant can also never be 0, so we know that it crosses at 2 points. So this is kind of an example of a problem that requires a little bit of algebra and thinking, but it's basically the same idea of what we just did before. It's just harder because you have to explain many different cases and not just one. Under what conditions is 2x squared plus kx plus 2 positive definite? Okay, so now they're saying that for this function, sometimes it's positive, sometimes it's negative. Depends on the k value. Okay, so again, we want to know the discriminant value. So we're going to put discriminant equals b squared, which is k squared, minus 4 times 2 times 2. A and c are both 2. So that is equal to k squared minus 16. And so we're saying, okay, when is this going to be positive definite? Well, if it is going to be positive definite or negative definite, it's going to be positive definite because the a value is 2. Okay? So now we're saying, when is the discriminant less than 0? If the discriminant is less than 0, then it's going to be positive definite. Okay? Okay, now we're getting into some old stuff for you. Okay, if we want to figure out values that make k squared minus 16 positive or negative, we need to factor. Okay, and the reason why is if we want to figure out the value of an inequality, first we need to pretend that it's like an equal sign. Then that finds out all the points which divide the k values that work and the k values that doesn't work. And if you don't know what I'm talking about, definitely come after school because this is a huge topic that is not easy to explain in 30 seconds in a video that's about a totally different topic. Okay, so I've factored k squared minus 16 into k minus 4 and k plus 4. Then I've maintained the less than or 0 here. Okay, and that's going to mean that there's two values that would be kind of the critical values that would be the exact values of k, where the whole thing flips from being positive to negative, and those values are positive 4 and negative 4. Because you can see if I put positive 4 in here, then the whole thing multiplied together is going to be 0. And if I put negative 4 in here, then the whole thing multiplied together is also going to be 0. So those are the values that make the thing flip back and forth. I'm going to mark those values, since they're critical, on a number line. So the k values of negative 4 and 4 are the values that make the discriminant equal to 0. Okay? That's obvious, right? Now the question is, what happens in between? What happens here? What happens here? What happens here? Is the discriminant positive or negative? Well, one thing that you need to understand is any of the regions in between these critical 0 points, if you figure out that one of these points is positive, then all the other points here are also going to be positive. How do we know that? Because it's a continuous function. The function is kind of like, it's nice and round. It doesn't like have discontinuities like, oh, now I'm going to go up here, and it's not like a crazy function. It's smooth. So if it's smooth, and you know that it crosses at these 2 points, then you know that if you figure out that it's positive here, it's positive at every other point in between these 2 zeros, right? So we know that. So we know that in between the negative 4 and 4, if we figure out that one point is positive or negative, the rest of them are also positive or negative. So why don't we take the easiest point to work with between negative 4 and 4, which would be 0. What if we put k equals 0 into this equation? We're going to get negative 4 times positive 4, which is negative 16, which is less than 0. So that means that the region between negative 4 and 4 k values gives us a discriminant that is negative, right? Because we tested one single point, which is the 0 point, and we discovered that the discriminant is negative there, so all the other points between negative 4 and 4 are also 0. Okay? So now let's try a really, like a right point. So let's try the point like 100. If we put 100 in for k, we're going to get 96 times 104, 2 big positive numbers. That is going to be a discriminant that is positive. And then if we put negative 100, we'll get negative 104 times negative 96. 2 negative numbers multiplied together also give us a positive discriminant. Okay? So now we've mapped out the possible values of the discriminant. At negative 4 and 4, the discriminant is going to equal 0. Between negative 4 and 4, the discriminant is less than 0. It's negative. Greater than 4, greater than k equals 4, the discriminant is going to be positive, and less than negative 4 is going to be greater than 0. So let's map it all out. I'm going to write it in the table. So if k is greater than 4, then the discriminant is positive. So it's positive definite. Oh, I'm sorry. It's not positive definite because the discriminant has to be negative for it to be. Yeah, so it's not positive definite. Okay. If k is between negative 4 and 4, then the discriminant is negative, which means it is positive definite. And last of all, if k is greater than 4, then the discriminant is greater than 0, which means it's not positive definite.